Okay, see Lindelof videos, calculus, and the chain rule. And here is the chain rule. It says if we want the derivative of f of g of x, of a function inside of a function, the way to find that is to take the derivative of the outside times the derivative of the inside. So I think these are really important things to note, that this is outside, and this is the derivative of the inside. So a really important place to start. So what I'm going to do here is this. I do really weird stuff. This is called U substitution, and it just helps me a lot. So this is what I want to show you. To me, this is the outside function. This thing right here is, this thing in orange is the outside function. So what I'm going to do is I'm going to do this. I'm going to call the inside function U. So I'm going to say let g of x, the inside function, equal u, and let that equal that whole inside function thing, which is x plus 5 to the 5th power, right, minus 1. So if I take that, I should have done this all in white, right, because that's what that should have been. And then if I say I want f of u, then what I'm saying is this. I want all this crap on the inside. I'm going to replace it with just a u, and I'm going to say, so here's all that crap on the inside. That's where this stuff went, right? It goes in here. And this 4 is this one. I'm like, okay, well, this is confusing, so I'm just going to put a u here. I'm not getting rid of it. I'm putting it aside for a second. It makes the calculus a lot easier to do. Because remember, it says here, I need the derivative of the outside and then the derivative of the inside. So I'm just going to take the derivative of the outside. So the derivative of u to the 4th power, right, is equal to 4u to the 3rd power. 4 times 1 is 4. We decrement the exponent by 1, so 4 minus 1 is this 3 here. So far, so good? All right. Then what I'm going to do is something that's kind of weird. I'm going to take this g of x here. So, okay, g of x, that's my u, right? G of x is that inside thing. And that was x plus 5 to the 5th minus 1, right? Now I have to use the chain rule again here. So this is a combination of chain rules here. So I'm going to take the derivative of the outside of this one. Say, okay, the derivative of the outside of this one is 5 times 1 is 5. All that crap in the inside stays in there, right? So this is just me differentiating the outside of this to the 4th power, right? The derivative of this is 0 times the derivative of the inside, but the derivative of x plus 5 is just 1. I'm going to put it here times 1 so you know that I did it, but that's how I'm going to stop. And then I'm just going to put all this crap together. Remember that we need f prime of g of x times g prime at x. So it says here that, so my f prime was this, right? So it's 4 times u, right? U to the 3rd, right? U to the 3rd. And you're like, Lindelof, how come you're not putting in u? Because it says here that u is x plus 5 to the 5th minus 1. So I need more room, don't I? Sorry. X plus 5 to the 5th, right, minus 1, right? That's me putting all that crap back on the inside. And then here's that derivative. This 4 is this 4, and this 3 is this one. So I have the derivative of the outside in orange here, and I just put the inside back in there, right? Times the derivative of the inside. So we found the derivative of the inside, right? We found the derivative of this thing. Then it turned out the derivative of that is 5 times x plus 5 to the 4th, right? And that should actually be our answer. It's really weird, and I do get that. There's not much algebra here that can be cleaned up, but 4 times 5 is 20, so I can have 20, right? And then I'm just going to put this crap again. Let me do it in white so you can see it. I'm just going to put this crap back in there. X plus 5 to the 5th minus 1, right? All to the 3rd power times this piece. This is the derivative of the outside, on the inside, x plus 5 to the 4th, right? So we have derivative of the outside times derivative of the inside. Not the easiest thing in the whole world, but let me, I guess, start by saying this, or finish by saying this. every time you do calculus, look at the problem and try to figure out what rule might I use, and then what pieces will I use to use that rule, and then start gathering pieces. Gather the pieces and then put them back into the rule. If you do that 9 times out of 10, your answer will come out good. So, hey, thanks for watching. And if you have any questions or comments, let me know. And if you haven't already subscribed, hey, please do.